There are two characters, two simple words that have puzzled humanity for thousands of years, and to this day, no one has truly understood them. Those two words are infinity. When we talk about the universe being infinitely large, or a number being infinitely big, what are we really saying? If you think infinity just means big, very big, or unimaginably big, then you haven't yet grasped the truly terrifying nature of this concept. If we hope to understand what the universe really is, we must first understand what infinity really means. Because in truth, there are many different levels of infinity. In the next few minutes, I want to take you on a journey from the tiniest particles of matter to the furthest reaches of the cosmos, through mathematics, physics, cosmology, and even philosophy. Together, we'll completely rethink what it means to exist in this universe. Let's begin with something small, the air you just breathed in. In that single breath, there were about 50 billion atoms. That's a 5 followed by 22 zeros. That's already impressive. But your entire body contains even more, about 7 billion atoms, or 7 followed by 27 zeros. Still not amazed? Then consider this. The number of atoms on Earth is estimated at 100 billion, or 1 followed by 50 zeros. At this point, the numbers start to feel overwhelming. But even these massive figures are trivial compared to the scale of the universe. Scientists estimate that the observable universe contains about 10 to the power of 82 atoms. That's a 1 followed by 82 zeros. And if we divide the universe into the smallest measurable chunks of space, called Planck volumes, we get around 10 to the power of 185, a number with 185 zeros. And yet, even these numbers are nowhere near the limits of human imagination. Because mathematicians have discovered a number so strange, so vast, and so beyond comprehension that it shakes the very foundations of what we believe numbers to be. That number is called Tree 3. So, what exactly is Tree 3? And why is it said to be more terrifying than any of the numbers we've just mentioned? To understand this, mathematicians came up with a simple-sounding game. It's called the tree game. If the universe is truly infinite, what does that actually mean? It means that not only is the universe unfathomably large, it's a place where everything you can imagine will happen, and not just once, but over and over again, an infinite number of times. In an infinite universe, there are infinite combinations of particles. Given enough space and time, all possible arrangements of matter will eventually occur. There will be stars exactly like our sun, planets exactly like Earth, and versions of you, identical in every way, who have lived your life, word for word, moment by moment. Somewhere out there, another version of you is reading this exact same sentence. And somewhere else, another version just blinked at a slightly different moment. This isn't science fiction, it's a direct consequence of infinity. Infinity doesn't care about probability. If something can happen and the universe is infinite, then it must happen. Not just once, but endlessly. There will be universes where everything is the same, except one blade of grass bends the other way. Universes where dinosaurs never went extinct. Universes where Earth never formed. And universes where you never existed. And yet, despite the overwhelming scale, despite the repetition, despite the paradoxes, this infinite landscape might still be governed by laws. Rules that, like the Tree 3 game, set boundaries, limits, and conditions even within an unending system. Infinity isn't chaos. It's structured complexity on a scale we can barely begin to grasp. That's the true terror and the true beauty of infinity. It's not just large, it's endless. It's a mirror that reflects every possibility, every version of reality, every version of you. Somewhere in that vast sea of possibilities, everything you've ever dreamed of and everything you've ever feared is not only possible, it's inevitable. In an infinite universe, there wouldn't just be one version of you. There would be countless versions, living the exact same life, experiencing the exact same thoughts, making the same decisions, again and again, without end. Because in the face of infinity, even the most unlikely events don't just become possible, they become inevitable, repeating forever. It may sound impossible, but this is the logical consequence of true infinity. That's why infinity isn't just a big number or a vast space. It's a concept so profound, so destabilizing, that it challenges everything we know about logic, reason, and even identity. The more we try to grasp it, the more we realize how small and limited our understanding truly is. But humanity's struggle with infinity didn't start today. Over 2,500 years ago, in ancient Greece, there were already people deeply disturbed by the idea. Among them was a mysterious group founded by the famous mathematician Pythagoras, known as the Pythagorean school. These thinkers believed that numbers and geometry reflected the perfect, divine order of the universe. They worshipped whole number ratios, convinced that elegant, rational proportions lay at the heart of all creation. To them, everything could be explained through harmony and symmetry. But their perfect world came crashing down with a single, seemingly innocent discovery. While studying something as simple as the diagonal of a square, they realized a terrifying truth. No matter how they tried, they couldn't express the length of the diagonal as a ratio of whole numbers. In other words, they had discovered what we now call irrational numbers, numbers that cannot be written as a fraction of two integers. Their decimal expansion goes on forever, never repeating, never ending. It seemed like a minor mathematical hiccup, but for the Pythagoreans it was like lightning striking their entire belief system. These endless, disorderly numbers shattered their idea of a perfectly ordered cosmos. They couldn't accept something so chaotic, so non-repeating. To them, irrational numbers were not just unsettling, they were wrong, even evil. Around the same time, another Greek philosopher, Zeno of Elea, introduced a different kind of infinity, one that haunted the minds of thinkers for generations. In his famous paradox, Zeno argued that to walk any distance, you first have to go halfway. Then you must cover half of the remaining distance, and half again, forever. Since there will always be another half to go, motion itself becomes impossible. This concept of infinite division, though logically sound, defied common sense. Philosophers of the time were deeply troubled. Some tried to ignore or deny the existence of infinity altogether. From the moment it entered human thought, infinity has provoked both wonder and fear. It has stretched our imagination, tested our logic, and shaken our most basic assumptions about the world. Even as philosophers trembled at its implications, mathematicians could not stop chasing it. At the end of the 19th century, a German mathematician named Georg Cantor made the bold decision to confront the concept of infinity, a mystery that had haunted philosophers for over 2,000 years. Rather than avoiding it, Cantor sought to define and understand the true nature of infinity through rigorous mathematics. His most groundbreaking insight was this: infinity is not a single monolithic idea. There are, in fact, different sizes or levels of infinity. Cantor pointed out that the set of natural numbers 1, 2, 3, 4 is infinite. So is the set of even numbers 2, 4, 6, 8. You might assume that there are more natural numbers than even numbers, but surprisingly, Cantor proved otherwise. He showed that both sets are examples of countable infinity, meaning that each natural number can be paired one-to-one with an even number. Despite appearances, they are actually the same size of infinite. This level is considered the smallest form of infinity. But what Cantor discovered next shocked the entire mathematical world. He proved that the set of real numbers, such as all the decimal values between 1 and 2, contains a kind of infinity far larger than the infinity of natural numbers. These numbers cannot be listed in a one-to-one correspondence with the natural numbers. This kind of infinity is called uncountable infinity. In other words, not all infinities are equal. Some infinities are infinitely larger than others. And the most unsettling part, even after you've understood the difference between countable and uncountable infinity, you can go further. There are infinities beyond uncountable infinity, higher levels, more complex structures, never-ending staircases of larger and larger infinities. No matter how far you climb, there's always another infinity waiting above you. These revelations shook the foundations of mathematics. And Cantor himself, after years of grappling with these mind-bending concepts, began to suffer psychologically. Toward the end of his life, he was hospitalized in a mental institution. His descent into madness is a haunting reminder that infinity isn't just a philosophical riddle. It's a concept that challenges the limits of human reason and mental endurance. And if that wasn't enough, what's even more astonishing is this: infinity doesn't just exist in math, it appears to exist in the real physical universe. Take black holes, for example. or the moment of the Big Bang. According to modern physics, the center of a black hole contains a point known as a singularity, a place where density becomes infinite and volume shrinks to zero. At this point, the known laws of physics completely break down. Space and time as we understand them cease to function. Our equations, so elegant everywhere else, fail in the presence of infinity. Yes, infinite density, infinite curvature. This is no longer theory on paper. This is the real possibility that infinity lives at the core of black holes, and perhaps even at the very beginning of the universe itself. When we return to the moment of the so-called Big Bang, the questions become even more complex. According to the Big Bang theory, at the very beginning of time, all the matter, energy, and space in the universe were compressed into a point of infinitely small size and infinite density. In other words, the universe itself may have been born from a true singularity, a point where the rules of physics collapse and infinity becomes real. But this raises a troubling question. What does actual infinity mean in the physical world? Does the universe really permit something as illogical and counterintuitive as a true infinity to exist? Or is this infinity simply a sign that our current theories are incomplete, incapable of accurately describing the universe's earliest state? To this day, scientists have no definitive answer. All they can do is acknowledge, sometimes reluctantly, that in certain extreme regions of the universe, such as the centers of black holes and the origin point of the Big Bang, our existing physics breaks down. This confrontation with real infinity forces us to reconsider our long-held assumptions. Perhaps humanity's instinctive fear of infinity isn't irrational. Perhaps infinity truly does exist in the universe. We just don't fully understand it yet. And if infinity really does exist, not just in theory but in reality, and if the universe itself is infinitely large, then the questions we face next become even more bizarre and disturbing than anything we've encountered so far. Because in an infinite universe, everything you can possibly imagine doesn't just become possible. It becomes inevitable and happens an infinite number of times. Not only that, but in such a universe, there would be an infinite number of people exactly like you. They would share your memories, your thoughts, and even the exact same feelings you're experiencing in this very moment. And it gets even weirder. According to quantum mechanics, the universe might contain phenomena far stranger than anything we've discussed so far. Take, for example, the famous thought experiment known as the Boltzmann brain. In simple terms, this idea suggests that in an infinitely long stretch of time, it's possible, however improbable, for a fully formed human brain to spontaneously emerge from quantum fluctuations in empty space. This brain would have real memories, consciousness, and even sensory experiences. But it wouldn't have a body, a history, or any connection to a physical world. It would simply be a free-floating mind, born from random chance in the vacuum of the cosmos. And here's the unsettling part. Even the moment you are experiencing right now, the thoughts you're having, the feelings in your body, could, in theory, be nothing more than a hallucination imagined by such a brain, a passing spark of awareness with no past and no future. This might sound absurd, but in a truly infinite universe, this scenario doesn't just become possible, it becomes inevitable. No matter how small the probability, given infinite time and space, even the rarest outcomes will occur and recur infinitely. This is the deepest horror of infinity. Not just mathematical or physical, but philosophical and existential. It confronts us with a logical paradox so unsettling that it forces us to question the very nature of reality itself. Can we trust our memories? Is the world we perceive around us actually real? Are we truly living beings in a consistent universe, or just momentary flashes of thought in an infinite sea of randomness? It's no surprise that these ideas can leave us feeling confused, even hopeless. Can human intelligence truly comprehend infinity? And more importantly, how should we exist in the face of something so vast, so unknowable? But maybe we're asking the wrong question, because if you look back through history, you'll see that human progress has always come from confronting the unknown. Time and again, we've faced what seemed like insurmountable limits, only to find that those limits became the launching points for new ideas, new civilizations, and new understandings of the universe. Infinity is no different. Yes, it may fill us with fear, with helplessness, but it also drives us forward, to question, to explore, to imagine. From the first Greek philosophers who trembled before the idea of infinity, to Pythagoras' world shattered by irrational numbers, to Cantor's descent into the mathematical abyss, to today's physicists staring into the black hole's heart. Every time we've faced infinity, we've been reminded of our smallness, our limitations. But we've also discovered a deeper strength, a hunger for truth, a courage to think beyond ourselves. And perhaps it is this very spirit, this will to push forward even in the face of the unknowable, that defines us more than anything else. In the end, infinity doesn't defeat us. It dares us to grow,